Aim. Let's examine how outliers affect data. And our lesson will be on outliers, lesson 14. All right, so 14.1, healthcare spending. The histogram and box plot show the average amount of money in thousands of dollars spent on each person in the country per capita spending for healthcare in 34 countries. So they've given a histogram and a box plot. And I imagine there are probably some words in here that we do not know. For those of you who do not know, per capita just means per person. So for each of these 34 countries, how each one of the data points was determined was they took the total healthcare spending and divided that by the number of people, which is in effect finding the mean, right? We're adding up all the numbers in the data set and then we're dividing by the number of numbers. So technically it's like the mean of whatever value you're measuring, in this case, healthcare spending for each country. Okay, so they've given us a histogram and they've given us a box plot. And 34 different countries around the world, however much I spend on healthcare. So one value in each set is an outlier. Which one is it? What is its approximate value? Okay, so take a second look at the data. Where can you find this outlier? Where do you think it is? And what would you say the approximate value is for that outlier? Okay, so one thing that is definitely tricky about this is that we're talking about thousands of dollars. So every number here really represents that much thousands. So 1,000, 2,000, 3,000, 4,000, 5,000, and so on and so forth. So an outlier, just by definition, an outlier maybe is someone who hangs on their own. An outlier in math is a point that is so extreme that it really does not represent the population as a whole. So we can see here that we've got an outlier right there and an outlier right there, which happens to be the maximum. I know it's one single maximum here because it's got a frequency of 1 on the histogram. So they want me to find out the value of this. Right, so an outlier is always going to be at either end. It's never going to be towards the middle because then that would be very close to the mean. So if I'm looking at this on the histogram, when I read this histogram, this tells me that the frequency of 1 is for a number greater than 9,000, maybe equal to 9,000, but definitely has got to be less than 10,000. And so maybe it's hard to see in your computer, but if you look here, if you take this all the way down, it actually ends up coming a little bit short of 10,000. So I'm going to estimate that it's 9.9 or 9,900. Oh, that's too much. 9,900, because it is in the thousands of dollars. So it's important. Sure, we can write 9.9 here when we're putting all this data in the graph, but you have to know that that 9.9 represents $9,900. All right. By one rule for deciding, a value is an outlier if it is more than 1.5 times the IQR greater than Q3. Show on a box plot that whether or not your value meets this definition of an outlier. So they're being very specific in their wording here by saying by one rule for deciding an outlier. So there are going to be multiple rules. Here's our first one. So we're going to take 1.5 times the IQR greater than Q3. So what that means is we've got Q3 and we're adding on to it 1.5 times the IQR. So this is finding an outlier that's on the upper side. So that's why they're giving us this one rule here. And so let's actually find out if this value is an outlier by definition. So Q3 is going to be right here on my box plot. And that looks to be about, let's say 4.8. Could be a little bit off. All right, and then I'm going to find the IQR. So that IQR is going to be equal to 4.8 minus whatever Q1 is. So So if we look at Q1, that looks to be, I'll say like maybe 2.2. I could be off by a tenth, which is, I guess, a bigger deal here because we're talking about 1,000, so I'm off. I could be off by 100, but it's good enough for the purposes of this activity. All right, then I got 4.8 plus 1.5 times this simplified, which is 2.6. All right, now I'm going to put all that into my calculator. I really could have put it all in at first. So I guess I'll do that now just to make sure, just to show you that you can. I don't need this parentheses up front, but it's always good practice to just put parentheses, maybe more than you might need. It's never too much unless you do it incorrectly. All right, so I'm getting 8.7 for my IQR. Okay. So that means that that limit for what an outlier can be occurs at right about here on my box plot. So any value that goes above it is going to be an outlier. I do know that this is the only outlier because you can see here there are no values on the histogram that occur after 8,000. It's all just this one value. So that is definitely an outlier, and it is the one and only outlier in the data set. All right, I also want to show you how to get an outlier on the lower range.